Coming up on Warplane. Within years of the Wright brothers' first flight, the flying machine becomes a lethal weapon of war. Over World War I battlefields, the warplane's roles are defined.
We need aircraft to carry bombs. We need small aircraft, very quick, to fight the enemy.
Spotters, bombers, and fighters arrive, and the age of the aces rises and falls.
Come in by surprise, make your shots and get out.
Between the wars, planes get faster and more powerful. Then World War II transforms air power.
We see the blending of the electronic revolution with traditional aeronautics.
Radar reshapes air defenses.
The Army and the Navy embraced radar with a vengeance.
And strategic bombing delivers new waves of destruction.
We are going over at low level with incendiaries, and we're going to burn those cities to the ground.
Conflict drives technology on Warplane.
The story of air power is a short one, the shortest in military history. From delivery of the first piloted airplane to the United States Army in 1909, to receipt of today's most advanced fighters, it has taken less than 100 years. But in that short span, the warplane has become the decisive weapon of all time. It turned warfare three-dimensional, and in doing so, tore up age-old rules of engagement. The fighter, the bomber, the pathfinder, the spy. Each would evolve according to its mission. This was a machine that could not only fight wars, it could end them, and potentially even prevent them. The story of war and peace in our time is the story of the warplane. There are those who say the F/A-22 Raptor may be the last fighter to need a pilot. For some time now, planes have been able to fly with little help from human hands. The Raptor controls most facets of its mission on its own.
It's all done by computers. I flip a switch, it says, hey, I want to slow the aircraft down, and I don't know how it happens. So now, the pilot is a limitation on a lot of different types of missions.
But for the present, at least, it is through men like Jim Hecker and his fellow pilots that air supremacy is maintained. It is through them that Langley's long tradition of combat air power will be kept alive. The fighter squadrons here are America's first. They date back to World War I and the very beginnings of military aviation. From these planes, we can trace the history through a series of bold technological leaps, all the way from the box kite to the stealth bomber. By creating and filling one role after another, planes transformed warfare, slowly evolving into the Air Force they are today. The F-22 Raptor is at the front line of that force.
Its role is basically to provide air dominance, and we're the bust-the-door-down kind of airplane. We shoot down these fighters that are now reaching parity with the F-15s, and we do that with them not even being able to detect us. Now that will enable other services, Army, Marines, Navy, etc., to come and bring the fight to the enemy.
The value of such an asset is now obvious. Not so in 1903, at least not to the United States Army. Following their historic flight at Kitty Hawk, Orville and Wilbur Wright faced unexpected indifference from the military.
The Wright brothers, I think from the very start, were very well aware of the potential military value of their airplane. Once they realized that it would fly and could stay in the air, they turned to the Army.
The only plausible customer was going to be the military of a great government who would pay the $100,000 they were asking for it.
But the U.S. government wasn't interested. In 1903, there was no threat of war, and no one was planning ahead. So the brothers bided their time, confident other parties would recognize the potential.
The Wright brothers dismantled their aircraft and stored it away until they made enough contacts in Europe in 1907, 1908 to go to Europe and fly.
While the Wrights sat on their invention, the idea of powered flight was taking off throughout the Western world. France led the way. But even though the brothers were giving other inventors time to catch up, they carefully kept their most important innovations to themselves. Their feats remained more legend than fact.
Some people in France learned of the experiments of the Wrights. And if you look at the first French biplanes, they are copies of the idea people had of the Wright biplane.
The French, by this point, had done a few things you could barely call flights. I mean, hops in a straight line, a little bit more. But when Wilbur finally shows up and flies and does circles and figure eights, the French were just astonished.
Why were the Wright brothers so ahead of the game? What secrets had they kept hidden behind closed doors for 5 years? Here in Warrenton, Virginia, craftsmen at the Wright Experience, working from the original notes and calculations of the brothers themselves, are rebuilding all of the brothers' early flyers. In this way, they are learning what the Wright brothers learned, just the way the Wright brothers learned it.
This was aviation at its very, very beginning. At the beginning of anything, it's dangerous. With us, we fully understand, with authentic airplanes comes authentic risk.
Much of the early risk for aviation pioneers revolved around the plane's center of gravity. Once airborne, the tilt of a plane's wings, called the angle of attack, would be critical to whether it stayed aloft or fell to earth. The trouble was, nobody could stay airborne long enough to determine exactly what that angle was. Wilbur Wright's approach to the problem was ingenious in its simplicity. He effectively turned the plane on its side. He fixed two metal plates to a bicycle wheel. The right plate was flat and created drag, just like a plane. The other was curved and acted as the wing. When the bicycle was ridden at speed, a point of balance was achieved. The wing plate effectively began to fly. With the wing flying, Wilbur could measure the actual angle it adopted. It was not what he expected from previous calculations.
Running down the road with this bicycle, the pressure from the oncoming air on this flat plate and the lift from this wing should balance each other and make the wheel come to equilibrium about 5 degrees off of center of the wing. When they tried it, they were getting something more like about 15 degrees.
Assuming that the 15-degree angle of attack was correct, they then needed to establish a wing cross-section, or airfoil. For this, the brothers moved their experiments back into their workshop. But they had built another ingenious makeshift device.
This is our copy of the Wright's 1901 wind tunnel. We reconstructed this balance just the way they did. It's made out of hacksaw blades and bicycle spokes and scraps of metal that were lying around.
The wind tunnel was rudimentary, but it allowed them to simulate flight. and it taught the brothers what they needed to know about the properties of different wing shapes. More importantly, it led them to one of their most truly significant discoveries.
The propeller probably is the biggest single thing that the Wright brothers gave us, and the thing that they've gotten the least credit for. The Wrights determined for the very first time that a propeller was a wing in rotation.
This was invention touched with genius. Everyone else at the time was thinking of propellers as rotary paddles, like the screws on a ship. A revolving wing, on the other hand, would need to be angled for lift. But since the outside of a spinning blade travels faster than the inside, they had to gradually shift the angle of attack along the blade's length to maximize efficiency. The Wrights quickly figured out what the correct twist should be, and in so doing, invented the modern propeller.
Today's wooden propeller is 84 to 85% efficiency. We tested a Wright propeller, and it ends up being 81% efficient. And that is just mind-boggling that they could be so close where we are today for the very first propeller.
The Wright brothers took nothing for granted. They thought through, invented, or thoroughly redesigned every element of their planes. Still, by 1908, the world was awash with aviation pioneers, all believing they were the ones who would come up with the crucial pieces of the aeronautical puzzle. Yet the Wrights shocked everyone when they arrived in France to show off their plane. Their performance proved they were still far ahead of any competitors.
The real secret of the Wrights was not propellers. Reciprocal engine? Of course, no. Not even the ailerons or the roll control. All this was invented before. To my opinion, what did the Wright was inventing flying. They knew something that nobody knew.
What they knew was how to control a plane once airborne. Wilbur Wright had hit on the idea of twisting the wings to steer his course through the air. It is a means of control still used to this day. Becoming airborne had been a challenge, but staying airborne was a singular triumph. And in 1908, the Wrights were still the only ones who could take control of the sky.
They had that information, the airfoil shape, the propeller, the 3-axis control, all of those things came from their test, and no one had a handle on it until they saw that airplane fly.
3-axis control is what kept them aloft. It allowed them to stop the plane from pitching forward unexpectedly, or rolling over and going into a spin, or yawing, slipping sideways into an aerial skid. By controlling these dangerous characteristics, the Wright brothers proved that sustained flight was truly achievable. Having convinced the world, they finally managed to convince their own tentative government. In 1909, the United States Army took delivery of a Wright Flyer, the world's first warplane.
The Wrights clearly tried to solace themselves with the idea that this invention was going to make war obsolete. The inventor of dynamite tried to convince himself of that. The inventor of the machine gun tried to convince himself of that. And they thought by being able to see everything, it would make surprise attacks impossible. It would make war really inconceivable unless a government was willing to just go into a grinding war of attrition, mutual annihilation, and they thought no sane government would do this.
But as history soon proved, the brothers' thinking was naive. In Europe, there was already talk of war. And not long after America's contract with the Wrights, the French followed suit. Great Britain, Germany, Russia, and Italy each set up aviation units within their own armed forces. But again, it was the French who led the way.
America may be the birthplace of aviation, but the French are the ones who raised the aeronautical child because of the pressures of trying to keep ahead of everyone else in Europe. The Germans will deflect and develop dirigibles. The British are hoping being on the island will protect them from all of this, and they realize later nothing can save you from aviation when Blériot flies the English Channel.
Louis Blériot, a French pilot, touched down in Dover, England on July 25, 1909. He barely made it across the channel in his flimsy homemade aircraft. His 25-horsepower engine was only just sufficient for the journey. But his success was a wake-up call for England. It took little imagination to see what threat a more powerful craft could pose to the island nation. The military powers of Europe also saw the potential and quickly embraced the technological challenge of creating an efficient, lightweight airplane engine.
The internal combustion engine was still a relatively recent invention. The engines were made of steel. They were water-cooled, and of course the weight of the radiator and water added enormously to it. To reduce the weight of it to work in an aeroplane was really quite a challenge.
The heavy, water-cooled engines just weren't practical for flying. But there was an imaginative alternative. In 1909, some enterprising French engineers began adapting lighter, self-cooling rotary engines.
Rotary engines were being used not only for cars, but also for motorcycles. And when I'm talking about the rotary engine, I'm talking about the whole of the engine whizzing round with all the cylinders sticking out and just spinning.
Here was a possible solution for the airplane. Still an internal combustion engine, but the cylinders were laid out around a central axis so that the pistons caused the engine to revolve at high speed. The plane's propeller was attached to the engine itself.
By revolving, the finned cylinders were very well cooled, so it saved the problem of having to water cool an engine, which reduced the weight of the engine.
The first rotary airplane engine was so small and comparatively light, it was christened the Gnome.
The Gnome and its fellow engines, Clerget and Larone, which came on quickly afterwards, were the lightest engines for their power that it was possible to find. These Gnomes were giving about 1 horsepower for 2 kilograms of weight, about 4 pounds of weight. That was an outstanding figure in the day, and that was why they were the preeminent choice for the aviator.
At 50 horsepower, the Gnome rotary engine answered the French Army's immediate needs. It was light enough for the early aircraft to take off with, and powerful enough to cover the distances required for basic reconnaissance. But as soon as the engines got more powerful, some very disturbing characteristics began to appear.
It must have been a genius or a madman who came up with a rotary engine. So when you've got a rotating mass like that, you're looking at a lot of centrifugal force, which makes the aeroplane interesting and difficult to handle in some circumstances.
Engines that work fine when bolted into an automobile or anchored to the ground respond quite differently in midair. So it was with the rotary engine.
It's difficult to turn the aircraft, it's difficult to pitch the aircraft, and when you do pitch and turn it, the movement of the aircraft is 90 degrees away from where you want it.
Takeoff is not a good time for the pilot to want to go one way and the engine another.
If you turn right after takeoff, there's a fair chance that you'd put the aircraft straight into the ground. So they did have their accidents.
Hugh Hunt from Cambridge University can explain some of the forces that bedeviled the early aviators.
I'm moving slowly here, or I'm moving fast.
The problem stemmed from the centrifugal force of the spinning cylinders.
This tennis ball weighs a few hundred grams. And I've got a 2 kilogram weight here, which is pretty heavy. I can lift that weight off the table with the tennis ball by spinning it around.
The force of the horizontally rotating ball is actually redirected 90 degrees to create lift.
The force is at right angles to the motion. I have here a gyroscope, and inside there's quite a heavy rotor. And this rotor, you can imagine, is the engine. Now, here is my string, and I'm going to pull my string straight downwards.
Pulling down sends the engine to the right.
Now that starts to be peculiar.
Nowhere was this effect more devastating than on the British Sopwith Camel. With a massive 150 horsepower engine and a body weight half that of its contemporaries, the Camel was a powerful and agile combatant, but its power made it dangerous.
The problem with the Sopwith Camel is that although it was the most successful airplane in terms of victories, half of the pilots that died in that airplane died in takeoff and landing accidents because it was so difficult to maneuver.
Flying with minimal training, pilots were going into combat without learning how to compensate for the behavior of the engine.
Let's suppose the pilot decides to do a right-hand turn. Well, the plane nosedives. The pilot finds that his yaw control has suddenly become a pitch control.
In other words, steering right sent the plane down, and left sent it up.
You do learn that if you want it to go in a certain direction, you do it 90 degrees removed.
Fighting the engine was what put the pilots in danger.
The pilot then tries to respond in some way to what's happening, then I can get into this kind of motion where I just don't know what I'm doing.
If they didn't crash first, pilots learned to accommodate the idiosyncrasies of the engine and in time turn the instability into an advantage in the air. By 1914, the rotary engine had become so popular, it was being manufactured under license in France, Britain, and Germany. It was then that the career of the warplane truly took off. On August 1st, 1914, Germany invaded France. Europe was at war. On September 2nd, a lone French aircraft spotted masses of hostile German troops east of Paris and alerted the French generals. The Battle of the Marne ensued, and with planes watching overhead, each side hunkered into the deep, distinctive trenches that would become iconic of the First World War.
The airplane proves itself very quickly once the front becomes stable and the trenches go up, because after that, your cavalry are no longer any good for reconnaissance. You have to rely on the airplane.
Only a month after Marne, on March 10, 1915, came the first clash in which the airplane would truly establish itself as a primary weapon of war. Neuve-Chapelle was a battle based on hundreds of photographs from aerial reconnaissance aircraft.
At Neuve-Chapelle, the effect of aerial reconnaissance on ground operations is undeniable, because really the entire British Army staff's attack plan depended completely on aerial reconnaissance and aerial photography.
Royal Flying Corps observation airplanes flew 7,000 feet above the village, reporting German movements as the attack began. No less than 1,500 maps of the German trench positions were distributed to frontline artillery positions.
It's still, after all these years, still got some glass plates in it. Well, I'm blessed. These are the photosensitive glass plates, and they would have gone in here and then that goes underneath there. The observer would look through the top here, then quickly put in a blanking plate, which is absent from this, and load the film in like that.
Using these unwieldy cameras, aviators redrew the map of northern France. For the first time, they were able to chart trenches, supply routes, ammunition dumps, and artillery positions. The commanders on the ground made quick use of the new information.
You have crews going out, taking the photographs. They're brought back to a mobile lab very close to the front. The prints are developed. Draftsmen and photo interpreters immediately process them up the line to the local military commanders.
They created a sort of photographic mosaic map of every square inch behind the German lines that they could pore over and spot where the dugouts were, the machine gun posts, where there were new lines being built.
Photographs a day or a week old are relatively obsolete. You had to have almost real-time imagery.
Taking photos was a very dangerous job because you have to fly straight and level to make the pictures.
Of course, while they're doing this, you make a very easy target for artillery, anti-aircraft fire. But they carried on doing it because if they didn't, then the infantry would suffer when they went over the top. They're real heroes.
Neuve-Chapelle was the first instance in which that kind of accurate mapping was used to support a really heavy artillery preparation.
In addition to reconnaissance of enemy movements, the planes also took on the role of artillery spotting. This was equally dangerous and equally vital.
The artillery observation aircraft were controlling the weapon system of the First World War, the guns.
What they would do is fire one in the general direction of the target and let an aerial spotter using Morse code sending corrections back to the battery.
The airplane was the artillery's eyes.
And so the two things together, aerial reconnaissance and artillery observation, meant that the Royal Flying Corps was performing for the first time the role that it would do for the next 3 or 4 years.
At Neuve-Chapelle, the nature of warfare changed forever. The eye in the sky had brought a third dimension to the battlefield. And for the commanders on both sides, there was now a new challenge: to blind the enemy.
The emergence of the fighter was a consequence of these observation aircraft, because if you saw one approaching your line, you were keenly interested in shooting it down.
The fighter was developed in order to accompany an observing aeroplane, so the roles of the two aircraft did split.
The most interesting aspect of pre-war air power is that no one ever experimented with air-to-air combat. The only time the British had tried it, they had put a very sizable 1 or 2 pounder gun on the plane, and when the gun fired, the plane went backwards and dropped 500 feet. That obviously was not going to play out. But now the question is, how do you arm an airplane?
Today's warplanes are armed to the teeth. But at the start of World War I, the aviator's primary role remained one of intelligence. Guns and aerial combat were still somewhat of an afterthought.
This is actually an RFC issue pistol from the First World War. Looking at the back of it, it was issued to 48 Squadron in May 1916, so it's a pretty early piece.
They had shotguns in the early stages of the war, and really very little damage was done until someone had the bright idea of fixing a machine gun to the aircraft.
Right, these are the two guns available to the RFC at the beginning of the First World War. This particular one is a Vickers heavy machine gun, and below it is the Lewis air-cooled gun, which is more of a machine rifle than a machine gun. The Lewis gun was generally used as a flexible gun on a scarf ring behind the pilot. Sometimes they were fitted on the top wing, right above the propeller arc, but they were awkward to get at, and that really didn't work very well.
The gunner effectively had to stand up, aim the gun at the aeroplane in front, and of course clear the blockages that happened with the gun. So this was all going on in a kind of a 50-mile-an-hour gale. What you wanted to do is to actually fly the aeroplane at your target. Of course, the problem was that you couldn't fire the gun through the propeller for obvious reasons, because you shoot the propeller off.
All sides in the conflict were frantic in their race to develop a safe, forward-firing machine gun. The winner would have the world's first fighter. Move 1 came from a newly enlisted French pilot who had already made somewhat of a name for himself on the pre-war aviation scene.
The birth of the fighter plane occurs in the mind of a pre-war French aviator, Roland Garros, an intensely patriotic Frenchman who didn't like the idea of his country having been invaded by the Germans. And he took it upon himself to find a way to seek revenge in the air.
Garros got his mechanic to attach metal plates to the back of a propeller, precisely in the firing line of a machine gun that would be rigidly fixed to his plane.
When the gun fired, if you were lucky, the bullet went through the propeller disc without hitting the propeller, and if it didn't, it hit the deflector plate and got deflected out of the way.
Garros's solution was crude, but it worked.
When this single-seater flies straight at them, they're thinking, well, is he crazy?
When we shall see him standing up, holding a gun, we shall move away. But he never stand up.
Garros just scared the fool out of the Germans. He shot down a number of aircraft with this strange technique because he's turned the airplane into a flying gun.
In a little over 2 weeks, Garros shot down 3 German planes. Then his luck ran out. On April 18, 1915, he was struck by ground fire. He crash-landed behind enemy lines with his secret weapon intact.
The German army decides, well, the best thing to do with this is to give it to one of our very few designers who designs light airplanes, just like the French are using, and that designer happens to be Anthony Fokker.
Fokker, a Dutchman building planes for the Germans, took Garros's innovation one step further. He synchronized the firing of the gun to the propeller.
Every time the propeller went past, the gun would fire, the other propeller would go by, and it would fire through the propeller with no problems. It was called interrupter gear.
Many derivative systems followed Fokker's. The technology advanced quickly, but the simple goal always remained the same: to keep the machine gun from tearing apart the plane's propeller when it fired.
This system relied on pistons operating from cams from the engine, very much in the same way as the mechanical system, but it had pressurized hydraulic lines going up to a piston on top of the machine gun, which prevented the machine gun firing when the propeller blades were in the way.
So we get a fire, 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 and so on. So the bullet passes through the red area of the cam.
The interrupter mechanism required split-second precision and extreme fine-tuning. Getting it right was a matter of life or death.
Done firing.
With Fokker's interrupter gear, the Germans won the race for the world's first fighter. Called the Fokker E-1, it was a monoplane nicknamed the Eindecker. Throughout the summer of 1915, it created havoc in the skies above northern France. The period was known as the Fokker Scourge.
These are the first, in a sense, fighter planes because they have a synchronized machine gun, forward firing, and the air war begins.
In the so-called Fokker Scourge, they make it very difficult for the French and the British to conduct aerial reconnaissance.
It proved very, very effective, and they completely dominated warfare for a few weeks or months until our own system had been developed.
Fortunately for the Allies, they didn't have to wait long until their own designs challenged those of the Germans. The Eindecker had the initial advantage of the interrupter mechanism gun, but other than that, it was not a good plane. At the University of Washington, aeronautical engineering students are doing stability tests on a 1/4 size Eindecker model. They hope to reveal just how unstable the German plane really was.
The kind of tactics that you'd like to have with a fighter are speed, the ability to get in and get out, and that means climb and dive performance, so structural strength helps with that.
The wind tunnel should give an accurate indication of the full-size Eindecker capabilities.
Okay, taking data.
I mean, right now the wing's at positive angle of attack, so we have lift. A wing to fly has to have an angle of attack. That's the angle relative to the oncoming flow. Now, when a pilot starts to climb, we have to increase the angle of attack. You can see how the drag on the wires is stretching the wires on the top back a little bit with the lift, too.
These are basic Wright brothers principles. But even with a slight increase in climb, the Eindecker is in trouble. It rapidly loses lift and approaches a stall.
Okay, let's stop here. Well, the problem is if the angle of attack gets too high, the air on the back side of the airfoil separates. In other words, it doesn't follow the surface, and we get what's called a stall. Now, a stall can happen in many ways. One is, on a typical airplane today, as we get higher and higher angle of attack, at the trilling of a jar wing, the air will stall and will move forward. So what happens is you actually start feeling the stall. You start getting a little buffeting on the wing. The pilots will recognize it. It's pretty high. Bring it down about 4 inches or so. In the Eindecker, if you have a sharper leading edge, when you get to a certain angle of attack, rather than the separation starting at the trailing edge, it starts immediately at the leading edge. And boom, all of a sudden you're flying, the next minute, slightly higher angle of attack, you're no longer flying. I don't know if we want to go much higher. The result could be a fatal spin even. I mean, it could be that catastrophic. Abrupt stall. Yeah. That was like, wow.
The world's first fighter was as dangerous for the pilot as it was for the enemy.
An airplane like the Eindecker against an airplane that would come out as little as a year later was nothing. I mean, it couldn't compete. In fact, barely compete with its own contemporaries. But it was that forward-firing machine gun that made such a big difference.
The Eindecker's reign was over in weeks, but the forward-firing machine gun was here to stay. It was easily fitted to increasingly formidable planes.
An aeroplane could go from a sketch into a flying machine within about 3 months.
And it wasn't just the planes that were being turned out quickly. With the war raging, pilot training was condensed into a few short weeks. Novices were thrown into skies that were becoming ever more treacherous.
Oswald Belke, the preeminent German fighter tactician, came up with the first real codified rules of aerial combat.
Instructed his pilot to fly grouped, with mutual protection, with a lot of speed, with the position of the sun in the back.
Never engage in combat until you've secured every possible advantage.
Come in by surprise, make your shots and get out.
Shoot at very close range and go away, whatever you achieve.
A new age was at hand, the age of the fighter ace, a concept of war not seen since the Middle Ages. These were the knights of the sky, locked in mortal combat. Every nation had its champions, and for every champion, the nations kept score. Britain had men like Billy Bishop, who alone downed 72 enemy aircraft, and Albert Ball, who shot down 44. France had René Fonck, 75 kills, and Georges Guynemer, 53. America had Eddie Rickenbacker with 26. Germany's first ace, Oswald Belke, had 40. And the greatest of them all, Manfred von Richthofen, the legendary Red Baron, had an astonishing 80 kills.
The ace is an invention of propaganda. It's good for the morale of population, and it's good for the legend. So every country put in front of his aviator the aces.
The aces, especially the Germans, had clout. They could go into the factories and weapons depots and demand changes. Their need for faster, more powerful planes drove aircraft design forward.
A plane at the peak of performance and the best fighter on the front. In 2 or 3 months, if someone introduces a new fighter, will find itself lagging behind.
Von Richthofen himself had a hand in the development of a new triplane from Fokker. Georges Guynemer, the French ace, had his own plane modified to fit his favorite gun. This was a new concept in warplane design, custom-built to meet the requirements of the job and the demands of the aviator. 1916 to 1917 saw some of the classic fighters appear on the Western Front, each striving to outperform the other. One plane that would have its weeks of glory was another favorite of von Richthofen's. It arrived in the spring of 1917 and was directly responsible for a time history remembers as Bloody April.
The Albatross D1, quickly followed by the D2 and the D3, they're solidly built, highly maneuverable. The Germans had the advantage of having excellent inline liquid-cooled engines, water-cooled in those days, produced by Benz and BMW. They've got enough power that they can carry not one, but 2 synchronized Maxim machine guns firing through the propeller. And that extra increment of firepower really made the Albatross a world beater.
Also unique about the Albatross was its fuselage. It was made from plywood in what is known as a monocoque construction, where the rigidity is in the shell. This eliminated the need for internal bracing. More space and better aerodynamics, a new word in 1917. This was a glimpse of the future. Northern France was first to feel the might of the Albatross. The planes came off the production line and were immediately shipped out to every German squadron. The skies were soon filled with them.
By the spring of 1917, fighter-on-fighter mass combats are a reality of war in the air, and they're a necessity for war on the ground. The German Flying Corps is well equipped with Albatross fighters, and they are able to take huge hunks out of the Royal Flying Corps. It's called Bloody April for good reason. The RFC suffered horribly.
The Royal Flying Corps would never forget Bloody April. 139 planes were lost in combat, more than in any other month of the war.
The airplane has become a lethal weapon, and the air war heats up.
The skies above northern France were witness to a new apocalyptic vision as wave after wave of fighters battled for aerial supremacy.
The air war over those battlefields will be on an enormous scale because you have to mass your fighter planes to try to stop the enemy from reconnoitering over your battlefield. The enemy is going to try to protect his reconnaissance aircraft with fighter planes. So in the same way that the ground war is war of attrition, in which men are being slaughtered in high numbers, the air war is starting to become on its own a battle of attrition.
Bloody April was perhaps the pinnacle of the fighter ace era. During that month alone, Baron von Richthofen notched up 18 more kills, but a year later, he too was dead, shot down in a dogfight with a squadron of Canadian pilots. In a stirring example of the chivalry of the times, he was buried with full military honors by the British. But his death was a harbinger for the end of his age. Warfare was once again moving on, and this time it was air power, not the air ace, that was leading the way.
Who was the most deadly killer? Richthofen shot down 80 aircraft, probably killed about that many people. But think how many people an observer and his pilot could kill on just one mission. If they caught a German counterattack in the open, they could bring a barrage down that would kill hundreds. They were the true killers on the Western Front.
The fighter had captured public imagination in a way the reconnaissance plane never would. But as citizens mourned the loss of their national heroes, military thinkers on all sides were awakening to the lethal efficiency of air power in all its roles. Reconnaissance, artillery spotting, and aerial combat had all found their places. But there was one potential role that had yet to be realized: bombing. Since before the war had started, military minds had been obsessed with the possibilities, but thwarted by the technology.
They started off by dropping literally artillery shells with fins on the end. That's how it all started. The pilot and the observer in the observing aeroplane thought, would it be good if we could just drop a shell directly onto the enemy below?
This is probably the earliest British bomb I've got, which was a handheld one, and this would have been chucked over the side of the aeroplane. Inside here is a propeller, and that was held in place with a thin piece of wire that, as soon as a bomb dropped, it broke, and this sent the propeller spinning and effectively armed the detonation system on it.
That was developed into bombs. Of course, they got heavier, and hoiking them out of the aircraft and dropping them over the side was no longer a practical proposition.
On the Western Front in 1914, there were no planes big or powerful enough to carry heavy bomb loads. But in the East, a different war was being waged. There, the Germans were bedeviled by a 20-year-old visionary who had developed a remarkable, almost futuristic new weapon. His name was Igor Sikorsky.
Sikorsky, before the war began, had developed something which, even to our eyes today, looks like a prototypical heavy bomber. 4-engine plane, something quite extraordinary at the time, could carry something like a crew of 10, significant payload, significant range.
The Ilya-Murames is startling for its time because it had an enclosed cockpit and passenger compartment. Inside, he had a table with linen on it with wicker chairs. There was lighting inside of the passenger compartment. The interior of the cabin was also heated, which is unbelievable for the time. This is 1914. And you could walk out on the upper part of the fuselage and stand atop the Ilya-Murames and look out as the plane cruised at 3,000 to 5,000 feet. And when you think of the enormity of the Russian landscape, the Russians thought of big airplanes, airplanes with range, capacity. It's not like living in Belgium.
Sikorsky's plane was an efficient bomber that caused the Germans real problems in the East. But they themselves did not develop their own big bomber until much later in the war, when they canceled production of the hugely expensive Zeppelins and developed the twin-engine Gotha bombers instead. The design was based in part on Sikorsky's plane.
In 1917, a new threat emerges with the Gotha. These are heavy-engined, for the time, bombers who could carry a decent payload of bombs in the sense of it was worth dropping, it was going to do some damage. The most effective raid was June the 13th, 1917, when they actually did hit London hard. The real damage they were doing is in nuisance value. You have to switch the lights up, you have to switch factories down, you close down the furnaces. That's not good for them. It all causes disruption. You don't stop transport, but you disrupt it. And in the end, what they were achieving was to be a bloody nuisance.
A nuisance? Yes. But the June 13th raid also killed 162 Londoners and wounded more than 432 others. The casualties created shockwaves throughout the establishment. Without knowing it, the Germans had set in motion a progression that would change the very nature of warfare. By highlighting the need for home defense, the raids prompted Britain to form the world's first independent air force. From then on, the RAF would be autonomous, operating alongside the Army instead of within it. The change would be a momentous one and would set the course for all future military campaigns. Only through a comprehensive and versatile use of the airplane in all its roles could one nation hope to prevail against another. Land power and sea power would no longer be enough. In 4 years, the airplane had grown from an unarmed, underpowered scouting machine, distrusted by its own commanders, into a primary weapon so valuable and so versatile, it merited its own command. The Great War had taken the airplane and turned it into a warrior.
We need aircraft to carry bombs. They will be slow, but they will be heavy, well defended, and carry a lot of weight. We need quicker aircraft to observe the territory of the enemy that can bring the information very quickly. We need small aircraft, very quick, very maneuverable, to fight the observing aircraft of the enemy, to fight the bombers of the enemy.
With the arrival of the bomber, the air armada was now complete. World War I had seen the emergence of the world's first integrated air force, created for reconnaissance, ground support, aerial combat, and bombing. But the end of the war did not mean the end of aerial progress. Only the first fledgling steps had been taken, and it would require many more advances and many more wars before the warplane would truly establish the age of air power.
For more information about the 100 years of military aviation history, please visit pbs.org. A multimedia timeline will reveal how warplane technology has transformed the way countries wage war. Warplane is available on DVD for $24.99 plus shipping. To order, call 1-800-336-1917 or write to the address on your screen.